Hey guys, I hope everything is going well. So today I was going to show you something that could be helpful to your projects and will just be helpful in life in general, and that is going to be forecasting. So we've used regression equations for prediction and estimation already, which you had to do a bunch in chapter 14. I'm not sure if you had to do it in chapter 15 yet, but we'll do it with a multiple regression today. And just to differentiate what I'm going to do today from prediction and estimation. So in prediction and estimation, we kind of predicted values for kind of any given values of independent variables, and we made those butterfly diagrams with the prediction intervals and the confidence intervals. So forecasting falls in that same category, but usually when somebody says forecasting, they mean over time. So doing a forecast of future guesses of some type of variable. So what I've chosen to do this on today is I downloaded a price house index of Ogden single family home prices. And you can get that from Zillow research data, has like a crazy amount of data. You could get these for basically any city or even pretty small towns in the United States. You can get their home price index. It's not, some people like it, some people dislike it. You can look at the methodology of how they come up with these prices, but it's a good place to start. And we can see over time, so we're starting in April 1996, and then going forward until the most recent data that I was able to get is February 2020. And so let's try to do a house price forecast for Ogden today. So this could obviously be valuable in a wide variety of contexts. Like if you're interested in selling or buying a home, it might be nice to make yourself a little forecast, and you could think, when's the best time for me to go on the market to look for a home or to try to sell my home? So let's start that today. And so the very first thing, I'm going to also introduce a new really easy control variable that you can use. But let's start off by going ahead and just looking at a line chart of this data. So oftentimes when we're dealing with time series, we might just want to take a look at what our variable of interest, home prices in Ogden, is doing over time. So right here, you can kind of see important historical events. This is happening in 2007-ish, 8-ish, obviously. We had that housing bubble that led to the financial crisis. And then we've recovered a ton from that. Ogden saw some of the fastest home price growth in the country in recent years, and that's reflected in this big upward sloping line. So like the Mountain West experienced really fast home price growth. Sorry about my melting face. I don't really know what's going on there. My computer's being weird. But the upshot is we always want to kind of start by looking at a graph of the data. And so what I'm going to do is notice on this axis, we could think of that as just calendar time. And when we're doing a forecast, like a really simple forecast might just be to use calendar time as a variable. One other thing I'm going to notice about this is that over time, it's not like a linear, it's not a flat line like the kind of stuff we've looked at in scatter plots. It has some curvature. Well, we can do that too by having non-linear terms in a linear equation. And I'm going to explain that today too. So let's get rid of this, but always a good idea to just start by looking at the data, really in any context, especially in a forecasting context. But I'm going to make a variable called time. If you have time series or panel data, you could make a really simple variable called a time. My first time period is right here. My second time period is right there. Double click it down, and now I have a variable called time. So we can use that as an independent variable and say, on average, when I go forward 1 month, because that's my underlying unit of time change, then the coefficient on that would tell me the average change. Now, because we mentioned that's kind of non-linear looking, maybe we want to add a non-linear term. So I could actually add time squared as well. That's just going to equal this number squared. All right, 1 squared is 1, 2 squared is 4, 3 squared is 9, 192 squared is 36,864. You could use this to memorize a bunch of squares and impress your friends at a cocktail party. I wouldn't do that. That wouldn't be a good use of time. But you could. So let's just run our most basic forecast is going to be just on these variables, and it'll help you to understand what type of information you need to make a forecast. Because notice that down here, if I want to forecast March 2020 prices because I don't have those yet. So I'm going to make a forecast of those. April 2020. May 2020. Now I'm going to be able to do that because I know that this is just going up by 1 unit, our time variable. In fact, let's lock view. I can freeze the first row. You can freeze panes to make it easier to look at an Excel spreadsheet if you haven't done that before. Right here, I'm going to freeze the top row, and then I can see what those variable titles are when I'm way down at the bottom of my data set. So that can be helpful. So notice I know what time is going to be in March 20. It's just going to be 288, 289, 290. So those are the type of variables I have to think about when making a forecast. If I'm going to forecast something in the future, I need to have the information that I'm going to stick in my regression independent variables today to do that future forecast. So we're going to think about that throughout this video. And this is kind of the easiest way to think about it. Because not only am I going to know that's 288, I'm also going to know that this is 288 squared, right? So I know those numbers and I can make that forecast. But unfortunately, it's not going to be that easy because time and time squared, as we're going to see in a second, is not going to probably create the best forecast for us. But let's go ahead and try it just to start out. So I'll do data analysis, regression, loading all my old stuff over there. So our dependent variable of interest is what we're trying to forecast. That's going to be Ogden single family, because I spelled it wrong, home price. Command Shift down arrow. Now we're going to just use these two time variables as our two independent variables. So a multiple regression with those two variables. Highlight the titles, Control Shift down. Looks like the numbers match, so I'm good there. I'll go ahead and plant these results kind of just over to the side. I'm going to give myself a little bit of space. Maybe G2 is good. So let's check that out. Now, a really important regression statistic when we're doing forecasts is going to be the R squared. Because I really want a good fit if I'm doing a forecast, or at least I want to know how good my fit is if I'm doing a forecast, because that's going to give me clues about whether I'm going to get a good or a bad forecast. This is going to be a pretty low R squared for a forecast. We're going to see that we can crank that baby up big time by adding some special variables in a second. But that's definitely an important variable to think about. Now, if we can go look at our coefficients, all of them are super statistically significant, super low p-values on time and time squared. And now, as you know, we can predict within sample by just getting the y-hats or the predicted values. So predicted home price. Double click that over. I'm going to go change this because I'm obsessive compulsive. So now it says Ogden single family home price. So now let's do our predicted values from our regression. I'm going to do equals intercept. I'm going to lock that on a Mac. You can actually do, I think, Option T, no, Command T. And then on a Windows, I think it's F4 to lock them. Before I was typing in those $signs, but there's probably a keyboard shortcut, or there definitely is a keyboard shortcut. I think it's F4 on Windows. It's Command T on a Mac, which is what I just used. Because I want to lock that intercept because that's a parameter of the equation, right? I don't want that to change. It's not a variable. Plus the time slope. So click on the time slope, lock that because that's a parameter too. But multiply that by a variable time right there, plus time squared slope, lock that, times times squared. And there we go. Now that's our predicted home price for that 1996-04. That's not that interesting because we already know what the home price index was at that time. So let's double click that down. But now we have a bunch of predicted values. These can be good to think about just to know how good of a fit you're getting, like looking at the errors. This isn't going to be the best fit, which we'll see in a second. But now in terms of making a forecast, these are wrong. I don't even know why it did that. But if I go right here and drag these down, now I actually have forecasts of home prices using my regression, right? Because like we said, I know that these numbers are just going to be going up by 1. I know that these numbers are just squared. So these are actually forecasted home prices. Forecasted home prices using this simple model. So it was pretty easy to create a baseline forecast. Now, I'm going to go ahead and guess, which this one is not a forecasted home price, right? That was in the data. It is an estimated home price given the data, but we already know that one, so that's not that interesting. But it's kind of good. Let's look at these home prices right here and compare them to these. What's pretty clear just from that comparison is that these are too low. Another way to see that quickly would be to go ahead. Let's drag this down a little bit more, actually. We could go way out, right? We can go way down there. You can label those. So there's all those months. I'm going way out now, multiple years. Double click these down. Now I have a really long forecast. And this is kind of cool how you can make a graph of this. So we're going to do this, Control Shift down arrow. And then I'm going to hold Command or Control to go over and highlight this too. And that's going all the way down. Insert, line. And now look at that. The blue line, of course, is the original home price. And now I have a home price forecast. I'd probably, obviously, as you know, you want to change this to something cool. I would probably change this in any forecasted one. Let's format that data series. So that's going to be our underlying data. Maybe we make that just a black line. And then maybe we make our forecast red and dashed or something like this. And notice that basically this black line ends before the red line because that's the underlying data. That only goes to February 2020. But this line keeps going because those are my forecast prices. Oftentimes it's good to like show the fit of that line throughout the data. And this again tells us, look, our red line probably is going to be too low because we've been missing quite a bit. And we're actually probably violating one of the assumptions of the regression model here, right? Because we talked about when we went over the assumptions that if you're missing low over regions, missing high over regions, you probably have what's called autocorrelation, and you probably don't have independent error terms, and that's a assumption of a regression model. So this is not a great looking forecast, but the easiest maybe to think about how we created the forecast because we knew what the values of the independent variables would be in the future. Let's go ahead and also we'd want to choose select data here, and a much better graph would actually show us the dates on the axis rather than just numbering the points. So that's always a good thing to do because now I can look at this graph and say, okay, here's my dates. And it's kind of nice actually that the format changes because now you can see exactly where the forecast starts because that's the format I used for the forecast. Well, this is the format of the underlying data, so that tells me where it is. Another cool thing you can do, insert a shape, a line, try to poke that guy right here. You can make it bigger and bolder. by formatting it. Now it's big. Make it dark gray, obviously. And now right there, that's like, hey, the forecast starts at this line. So all types of stuff that you could do like that with a forecast. Now again, this is obviously not the greatest model. That red line is not giving us the greatest forecast. So let's check out a new model over here. So this is going to be our first model. In terms of organization of a spreadsheet, I'm going to go right here. I'm going to dump a bunch of black paint in this column. And now it's like, okay, first model to the left of that line, second model to the right of that line. We will use the same set of variables to start out, but I'm going to go get rid of some of this stuff that I did down here for that forecast. So let's clear this out. And then I'll go up to the top. We also want to get rid of this. I probably shouldn't have just not have copied this over. Let's delete that because we're going to make a new model, so we'll have new predictions. Now, a really powerful way to easily make this a better model is to use what's called lagged dependent variables. So I could think about like house prices, if they're rising over time. House prices and a lot of types of prices are what we'd say are sticky. Like if last month house price in Ogden was 200 grand, it's unlikely that next month's will be 500 grand or $10,000. It's going to be something close to 200 grand. And we can use that information. We could use last month's house price as a predictor of this month's house price. So let's try that real quick. So I'm going to call it L. So that usually is how people say lagged. So this is going to be lagged home price. And it's really easy to make this variable. I'm just going to leave myself one row, and I'm going to do equals, look back one period, enter, double click that down, and now I'm just pointing back 1 month at a time. And think about, again, forecasting. I will know this month when I'm making my forecast what last month's home price is. So that information will be available to me. There's going to be a little bit of cost by only using one lag, however, which we'll see in a second. So let's go ahead. We also, one cost is that you lose an observation by lagging. We lagged one period, we lost one observation. We're going to lag more periods in a second, and you'll see that we get a bigger loss of information. So before I do this, I'm going to do Command-C, Command-V, and paste this as values. Where'd my little menu go? I'll just paste special, I guess, so that I can click values. Usually you get that little menu to do it, but I don't see mine. So that just took away that formula, right? Because I'm going to delete this, and that would have led to a problem if I deleted the reference to that cell right there. It would have been like, hey, you just deleted the thing I was looking at, so you have to paste as values before you delete that row. Well, now let's check out what we get when we do a regression with these new variables. So I'm going to do regression, go over here. My dependent variable again it's the same one, but I dropped a value, remember, because I deleted that row. So you have to think about that when you're reloading it. So I'll highlight my dependent variable, Ogden home price. Now my new set of independent variables, now I'm going to have 3 independent variables because I'm going to keep those other ones. So these 3, Control-Shift, down arrow. We got labels. Let's put this over here again, maybe in V2. So V2 right here. I think we're good to go. Oh no. So I have to go look at the bottom because somewhere I went too far or something. Something's wrong with the bottom of the data set. Maybe. Oh no, I forgot to do labels. I didn't include the labels when I did my dependent variable. See how it starts at P2? So always making sure that these numbers match. So now it should work. Okay. Look at that R squared. Look at how much better our regression got by including a lagged dependent variable. We're explaining almost 100% of the variation in home price now. So we're going to get a lot better of a forecast, basically, is what that means. Now I can do predicted home price. Double click here. Now I'm going to do equals, intercept, Command T, plus time slope, Command T to lock it, times time right here starts at 2. That actually doesn't matter, so don't worry about that as long as it's going up by the same amount each time. Plus Command T, or no, I don't want to do that yet. I want to click on my time squared slope, Command T to lock it, multiply by time squared plus that lagged dependent variable slope, Command T times the lagged home price. Okay? And we can already see probably that we're getting much better predictions if you just compare these two numbers. Let's go all the way down to the bottom. Now the cost of only doing one lag is now I can only go one. Oops, that's not going to work. I have to highlight them both so as we're counting up. Now those, before I could drag those way down, the time and time squared, because they go together. However, for the lagged home price, this is going to equal 1 month before right there. So notice I can only do that once really because I don't have home prices going forward. So I can only predict 1 month forward if I only go back one when I use my lagged variable. And now I can get this, and this is my prediction for my March home price. Now that's kind of lame because it's already April. It's just a matter of the data being released. I mean, I've predicted what Zillow will release for their March data, which they just haven't released yet, but it's not that great in terms of like, well, should I buy a home in March? Well, you can't, unless you have a time machine, but you shouldn't really be dealing with these things if that's the case. So that's fundamentally how we do forecasting, and these are going to be much better forecasts with that lagged dependent variable. So that's pretty powerful. So now let's think about how we might go forward farther. Let's try to predict for the next 12 months, starting at March, but then 11 months after than that, and then we'll have some stuff going forward. So this is model 2, that lagged dependent variable. And we see that is a very powerful thing to do, a lag dependent variable. But there's a cost to it, is that we don't get to go as far forward. But what if we go back? Let's go get our original data. Actually, let's look at the plot again, because this is going to be crazy how much better of predictions we get out of this model. So let's do Control-Shift down arrow. Command or Control to move over here, Control-Shift down, and those are my actual and predicted home prices. Insert, line, get rid of short title. Oh no, there's only one line. Actually, there are 2 lines, but that's how much better the price forecast got. How crazy is that? That's a way better model in terms of fit. That's where that R squared is coming from. 100% of the variation is in that model. That's why it's such a good fit. So that blue line, if you look really closely, maybe if I make it really big, there's a blue line under there behind this orange line. That's actually, so what did we do before? We did our predicted format data series as red dashed. That'll help us see the one below it by making it dashed. And now you can see that blue line back there I don't even know if I can click on it. Because it's so tight of a fit. Sometimes this is hard. Format data series. It didn't even give it to me that time. So maybe if we make this really big, we can try to get our hands on that blue line. Well, actually, you know what we can do? That's way easier. Go click on this or out here. There it is. And so we made that one just black. And now you can see better. It's a better comparison because that's what we used before. We'd, of course, want to put the dates at the bottom of this, but I won't waste your time with that because I already showed how to do that. But I mean, just look at these two fits. When we just use time, since we use that lagged independent variable. I mean, that's a powerful tool to use in terms of forecasting because we just added so much more information by using last month's home price. But again, the cost was that we could only predict 1 month forward with that particular model. But now let's try to use a similar idea. I'm going to drop these guys because I think it's making my computer get a little bit angry that I'm using all those. Let's try to kind of have a balance between those two trade-offs. So when we just use time, we could go way forward with our forecast. But when we add a lag-dependent variable, we couldn't go that far forward. So let's try to get some balance between those trade-offs by copying the original data again, pasting it over here, painting this black so that we can have a nice separation between our different models. Now I'm going to do L dot, let's do a year forecast, L dot 13. So instead of doing just L dot, which would be 1 lag, I'm going to do 13 lags. And I'll call that L dot 13 home price. Now, the home price 13 months ago is not going to be as good a predictor as the last month's home price. That's the cost of doing 13 lags. The benefit is that we will be able to pull forward 12 periods, basically, or 13 periods, but we have that weird February thing just because the March data isn't available yet. So like 12 months forward, including April. So how am I going to do this? This is where I would have put my 1 lag, right? That's where I did it in the last example. So 1 lag, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 equals that home price. Enter. That's 13 months ago's home price. Double click that down. Copy it and paste it on itself, or I guess I have to do, I don't know where my little menu is going, but we'll do paste special values because we're going to do the same thing where we're now also another cost of doing all these lags is we're going to lose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 rows of data. So we have a smaller sample size by giving up those lags. All right, so here's our new data set. Let's see how this works out by running our regression. So data analysis, regression. So I'm going to go ahead and click these home prices because, of course, the length of this is different now because I deleted a bunch of rows. So that's my dependent variable. Grab our set of these 3 independent variables, Control Shift down, YRU0 down here. Oh, I accidentally forgot to delete these are like the forecastings I made that first time around, right? But that's okay because we can go ahead and say this has to end at 275, right? So now it's only going to this right here, because that's 275 where that ended. See that right there, 275. And now I'm ending the independent variables there too. And so this shows, actually, this is kind of helpful because this shows how far forward I'm going to go. Because how far forward am I going to be able to go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? So we won't be able to go farther than that. If you want to go farther than that, you have to lag even more. And think about that trade-off when you're doing that. So let's put these data, or these results, over here in AK. So notice that now our R squared is lower because we're facing that trade-off. 13-month ago home price is not going to be as good of a predictor as 1 month ago home price. So delete. If you were doing a hardcore model, you could do the model with 1 lag, 2 lags, 3 lags, and then build it out. So you could use your 1 lag model for next month, build a model with 2 lags for 2 months out, and then so you're not giving up that R squared. And as you're giving up your R squared as you move out forward. That would take a really long time for this video, but you could imagine doing this model to make the 1 month forecast, L2 to make a 2 month forecast, L3 to make a 3 month forecast, and so on. That would be a really rigorous way to do that. I don't want to waste your time in this video, but let me know if you have questions about that, because that would be a more rigorous way of doing such a forecast. Let's get down and clean up the bottom of this, since we know that we're not going to be able to predict this far out. So we'll go ahead and just clear those guys, because we do have our independent variables to make these predictions. These are going to be predicted, or sorry, no, these are going to be our predicted home prices, because we're going to now plug in our predicted values, but actually we're going to stick them over here, because I'm going to make a variable called predicted home price for this model now. So now we're going to go ahead and go equals intercept lock it plus slope lock it, multiply it by its respective variable. That starts at 14 now, of course, because we dropped a bunch of the lags, or the early months, plus this slope, lock it, nope, that didn't lock it, times squared. Notice how helpful it is to include labels. Like early in the semester, you're probably like, this guy's crazy, why does he include labels? But now you can see it's very helpful when I'm making these predicted values to just keep myself organized by including labels. This guy, lock it, multiply it by its friend right here, enter, double click it down. Now that followed us all the way down. Notice these are all forecasted prices. Now, March again isn't that interesting because we already know that value, or we don't know the value, but that's kind of just predicting what Zillow is going to tell us any day now. I think that gets released like mid-April. But April, we don't even have just a tiny bit of the data. So the transactions, we're only a week into April. So like we don't even have some of that data. Clearly we have none of the May data. So these are truly out of sample forecasts. Now again, we probably want to compare some of these values. It looks like on average, we're a little bit high. So this is probably still not the perfect model, but it's going to be better than that first one where we just use time and worse than the second one, basically is what's going to go down. So let's go ahead, Control Shift down to do our comparison. So I just highlighted my actual home prices, Command, click on that, Control Shift down, Control Command, sorry, I mixed those up depending on Mac or PC. But now we can insert our line graph. And that looks still pretty good. I mean, obviously not as good as the one with just a single lag, but definitely better than the original one that just had time. And so now we can click on our two different series. Format data series. That's our underlying home prices. So that's the one we were making black before. This one we were making red, dashing it through the white snowy background. Whoa. Control Z, Command Z. Let's make this bigger. Let's make it our Ogden home price forecast. Let's make sure that we're putting actual months on our y-axis right here. Okay. And so now you can see, and again, you can kind of see where the forecast starts. If we spread that out a little bit, we can get a better, more granular look at those labels. So there's our house forecast. You might even do insert one of those shapes. Try to stick it right where the forecast starts. We can move that with arrows, I believe, to try to get it right where it should be. And this right here is the type of chart where your boss is just like, yo. Right, let's make it, what's the magic number? Oh, we should make it gray. Maybe we should make it go to the top of here. You guys can stop watching now because now I'm just having fun with this because I love charts. But now we're dividing our world into our, hey, look, this is how my model fits. The historical fit, well, I'm over here. The historical fit of my model. And then a little forecast right there. Now, again, you can try to go farther out. You could apply confidence intervals to this. You could write prediction intervals to this, just like you've seen in the past. And you could just get crazy with it and make the craziest chart anybody's ever seen, right? This is the chart that lands you that job right here. All right, so let me know if you guys have any questions. Very powerful tool to have in statistics. Rarely do ever people go backwards and ask about your forecast after the fact. It's kind of shocking. People only care about your forecast in the future, but rarely do people are like, hey, your forecast was super bad. That never happens. I don't know why. But I'll see you guys later. Have a good one.